In this video, I will discuss a JEE Advanced PYQ from the topic Current Electricity. This question is based on series and parallel combination of resistors, and power dissipated in the resistance is V into I, which is equal to I square R using the Ohm's law, V equal to I into R, and also equal to V square by R. Timestamps are given in the description box. You can watch parts of video if you are running short of time. This is the question. We can read it. In circuit 1 and circuit 2 shown in the figures, R1 equal to 1 ohm, R2 equal to 2 ohms, and R3 equal to 3 ohms. P1 and P2 are power dissipations in circuit 1 and 2 when the switches S1 and S2 are in open conditions, respectively. Q1 and Q2 are power dissipations in circuit 1 and 2 when the switches S1 and S2 are in closed conditions, respectively. Which of the following statements are correct? Statement A, when a voltage source of 6 volts is connected across A and B in both circuits, P1 less than P2. B, when a constant current source of 2 amps is connected across A and B in both circuits, P1 greater than P2. When a voltage source of 6 volts is connected across A and B in circuit 1, Q1 greater than P1. Statement D, when a constant current source of 2 amps is connected across A and B in both circuits, Q2 is less than Q1. You can pause and attempt this question. So there are two circuits, 1 and 2, and the switches are open and closed. So in the first circuit, in the switch is in open condition, the total resistance across AB in circuit 1 when S1 is open. So the current which comes here, the same current will flow here because this switch is open, and it will split into two branches. So this one and this branch are in parallel. So to get the effective resistance between A and B, R2 and R3 are in series. So the total resistance is R2 plus R3. That is in parallel with R1 by 2. And this full combination is in series with R1. So to this, if we add R1, that is the resistance between the points A and B when S1 is open. R2 is 2, R3 is 3, so it is 5 in parallel with R1 is 1 with half plus R1 which is 1 ohm. So two resistors in parallel. So it is product of the resistance 5 into half divided by sum which is 5.5 plus 1. So this is 2.5 by 5.5. So it is 5 by 11 plus 1. Simple calculation, 2.5 by 5.5 is same as 25 by 55, which is 5 by 11. So this is 16 by 11 ohms. This is the resistance across AB when S1 is open. So we'll remember this result. Next is when this switch is closed. So resistance across AB in circuit 1 when S1 is closed. So when this switch is closed, the current which comes here, all the current will flow here itself because this is a zero resistance path and this current is 0 amps. So it's as if this resistance is not there. Then the total resistance is the combination of these two I think we kept the previous one, that is R2 plus R3 in parallel with R1 by 2. So R2 plus R3 is 5 in parallel with half. Product is 2.5 divided by the sum is 5.5, which is 5 by 11 ohms. Similar analysis for the second circuit. So resistance across AB for the second circuit when the switch S2 is open. Two cases, the switch is open and switch is closed. So when the switch is open, R1, R2, R3 are in parallel. No current is flowing here, so this is not there. So that means the total resistance is, we have to do the 1 by Rp in parallel combination. The reciprocal of resistance will add 1 by R1 plus 1 by R2 plus 1 by R3. So this is LCM 6. So 6 plus 3 plus 2. So this 11 by 6. So take the reciprocal, you get 6 by 11 ohms. Because in parallel combination, reciprocal resistance add. So this is 1 by ohms. So resistance is reciprocal of the final answer, which is 6 by 11. So resistance across AB in the second circuit when S2 is closed. So when S2 is closed, now we have 4 resistance in parallel. So the total resistance in the switch is closed is 1 by R1 plus 1 by R2. R2 is 2, 1 by R3. R3 is 3 ohms plus 1 by 2 R3, which is 1 by 6. R3 is 3 ohms. So 3 into 2 is 6 ohms. So here again the LCM is 6. 6 plus 3 plus 2 plus 1. So this 12 by 6, which is 2. So reciprocal is half ohms. Option A says when the voltage was 6 volts connected was A and B, P1 and P2. So P1 is the power dissipated in circuit 1 and 2 when the switch is in open condition. So P1 is the voltage connected, that is 6 volts. So 6 square by the total resistance is 16 by 11. And P2 is the power dissipated in circuit 2 when 6 volts is connected across the terminals A and B. So again V square, that is 6 square by total resistance 5 by 11. So obviously P2 is more because the denominator here is less. So P2 is greater than P1. Statement A, when voltage of 6 volts connected to A and B in both the circuits, P1 is less than P2. P1 is less than, so statement A is true. So remember the answer here. Statement A is true. And for statement B, constant current source 2 amps is connected across A and B in both the circuits. So you have to compare P1 and P2. So when current source is connected, power dissipated can be written as, this is option A. For option B, power is, when current source is connected, we can write the power dissipated as I square R, and I is 2, so I square into R is 16 by 11. So in the second circuit, when the current source is connected of 2 volts, 2 amps, ask the total resistance when the switch is open, so it's 6 by 11. So P1 is more here. For the condition statement B, P1 is more. So statement B is also true. For statement C, when 6 volts connected across A and B, you have to compare Q1 and P1. For statement C, you have to find Q1, that is voltage source of 6 volts is connected, so V square by R, but when the switch is closed. So to use this one, first circuit, it's 5 by 11. And then P1, same voltage source 6 volts, and the switch is open, so 16 by 11. So obviously Q1 is more because the denominator is less. So Q1 is statement C says Q1 is more than P1, which is true. So C is also true. Statement D, current source 2 amps is connected across A and B. Q2 we have to compare with Q1. For statement D, we have to find Q1, which is I square R. First circuit when the switch is closed, so it's 5 by 11. And then Q2, power dissipated when the current source of 2 amps is connected, and when the switch is closed, so it's half. So this is less than half, so Q1 is less. Statement D, current source is connected, so power dissipated I square into R, and Q corresponds to the closed situation, closed switch, so it's I square into this resistance in the first circuit, and the second circuit is I square into this resistance half, and this less than half, so Q1 is less. Statement D, it says Q1 is more, so D is false. So the correct statements are A, B, and C. A, B, and C are the correct statements. D is false. So this would explain here. To find P1, the power dissipated in circuit 1 when the switch is open. So this is the circuit. So here R2 and R3 are in series in parallel with R1 by 2. In parallel with R1 by 2. And then that combination is in series with R1. So first this thing can be found as R2 plus R3 is 5 in parallel with half, which is 5 by 11. And this has to be added to 1. So the total distance is 16 by 11. To find P2, the total resistance is, this switch is open, So R1, R2, R3 in parallel, this resistance will not come in the circuit because there is zero current here. So parallel combination of 1 can be understood as 3 by 3. So 3 by 3 in parallel 3 is 3 by 4. And then in parallel with 2, product by sum, 6 by 11. So option A is comparing P1 and P2 when a voltage source of 6 volts is connected. So V square by R, and the total resistance in the first circuit when the switch is open is calculated as 16 by 11. So 16 by 11. And power P2 is voltage source and the total resistance is 1.5 by 2.75. So obviously P1 is more compared to P2. This is less than 1, this is greater than 1. So statement A is true. Statement B, current source is connected and you have to compare P1 and P2. So the power dissipated is I square R, I square is 2 square, and R in the first case is 16 by 11, and in the second circuit is 1.5 by 2.75. So 16, so this is greater than 1, this is less than 1. So P1 is greater than P2, so statement B is true. For statement C, we have to find Q1, that is when the switch is closed. When the switch is closed, the current which comes here, all the current will flow here, zero current here. So it's as if this thing is not there. So only these two will come. So R plus in parallel with this one, that is 2.5 by 5.5. So Q1 is when the voltage source of 6 volts is connected. So V square by R, 36 by, this is same as 5 by 11. So 5 by 11. And P1 is same voltage source connected, but the switch is open. So 6 square by RT is 16 by 11. So Q1 is more. So statement C is true. For statement B, we have to find Q2. That is, this switch is closed. We have to find the effective resistance. So all the four are in parallel. So that the effective resistance is half ohms. So Q1 is I square into R when this thing is open. So that is 5 by 11 calculated previously. And Q2 is I square into this R, which is half. So this is more because the first one is more than, less than 2, less than half. This half. So Q2 is more than Q1. So statement D is not true.